Now we'll discuss about the step down bridge type cycloconverter. Let us define what is a cycloconverter. So it is a AC to AC converter without any DC link. And secondly, we can define it that it is a device which can convert a fixed frequency power supply to the variable frequency power supply. So cycloconverter is classified as two types, that is the step up and step down. We are going to discuss here about the step down cycloconverter. So what is step down cycloconverter? Step down cycloconverter is defined as the output frequency is less than the input frequency, then it is called the step down cycloconverter. So let us see the circuit diagram of this step down cycloconverter. That we have a total 8 group of thyristors here, total 8 thyristors here. That is 4 thyristors are named as a P1, P2, P3 and P4, and rest 4 are named as a N1, N2, N3 and 4. So these P1 to P4 thyristors are called the positive group thyristors, and N1 to N4 group are called the negative group of thyristors. One thing is to be noticed here that the negative group of thyristors from N1 to N4, they are connected in anti-parallel with the positive group of thyristors. So now in this type of cycloconverters, our motive is to design a circuit so that we can step down frequency across the output voltage. So in this case, we have taken a 4-cycle input supply frequency that has been shown here with the help of waveforms, that is from 0 to 8 pi. We have taken a 4-cycle input supply frequency that we are going to apply across the step down cycloconverter, and our motive is to design a circuit in such way so that we operate these thyristors only to receive a single cycle output voltage, because we want to convert down output frequency to 1/4 of the input supply frequency. Now this is the circuit diagram of the cycloconverter. We have connected a load between two group of the thyristors, that is from the positive group and from the negative group of thyristors. In between we have connected a load, and this is the V0, that is the output voltage across the load, and this is the I0, that is the current flowing, output current flowing across the load. Now we will discuss one by one for each case that how this step down cycloconverter will operate. We have connected a positive supply this side, and similar way a positive supply is connected in negative group of thyristors also. So let us first discuss about the input supply when we have applied between an angle 0 to pi. So once we have applied the input supply between angle 0 to pi, so how the polarity will be received in this positive group thyristor, that is this upper side will be positive, it means point A is positive and this point is negative. So once point A is positive, it means thyristor P1 and thyristor P2 will be in conductive mode and they are in forward bias. Similarly, this side also, if this is the positive and this side is negative, so thyristor N3 and N4 will be in conductive mode, but we will not supply any trigger pulse to thyristor N3 and 4. We are only going to supply the trigger pulse to thyristor P2 and P1, as we have to step down the frequency. So once P1, P2 are supplied trigger pulse and this P1 starts conducting, so current will flow from this through thyristor P1, it will come back towards the load, and from point A to point B through this thyristor P2, it will complete the circuit. It means during this conduction we have received a positive polarity output voltage across the load point A and B. This is the positive polarity output voltage when thyristor P1 and P2 are conducting. Now let us switch over to the angle pi to 2 pi. So once we have a negative input supply voltage, that is from an angle of pi to 2 pi, it means this side will be positive and this side will be negative. So in this case, thyristor P3 and P4 will be in forward conduction mode. So we will supply a trigger pulse to thyristor P3 and P4 only. We will not supply any trigger pulse to thyristor N2 and N1. So once we supply a trigger pulse to thyristor P3 and P4, then supply current will flow from here, from point B toward thyristor P3. It will come back toward the load from point A to point B, and then it will go back through thyristor P4 to negative side. It means for this negative input supply voltage, we have again received the positive polarity output voltage, this one, where thyristor P3 and P4 are conducting. This to be noticed here that in each case we are giving a trigger pulse to thyristor at an angle alpha. That's why we are getting the output voltage with some delay angle after pi or after 0 angle. Now let us move toward the next positive cycle, that is between angle 2 pi to 3 pi. So we are applying again positive input cycle at the cycloconverter. So this will be the positive, this will be the negative, and thyristor P1 and P2 will be in forward conduction mode. So we will supply trigger pulse to thyristor P1 and P2. We will not supply any thyristor trigger pulse to these thyristor N3 and N4. So in this case, current will flow from this positive toward the thyristor P1, and then it will come back to the load from point A to point B. Then it will come back to thyristor P2 and goes back toward the negative. It means for this positive input supply, we have received again the positive polarity output voltage, that is P1. This is the input output supply voltage, positive polarity. So in this case, thyristor P1 and P2 are conducting as shown here. Let us move the again next step, that we have supplied a negative input supply voltage from an angle of 3 pi to 4 pi. So once we supply the negative input supply, so this side, lower side will be positive and this side will be negative. It means thyristor P3 and P4 will be in forward conduction mode. So we will supply trigger pulse to thyristor P3 and P4 only. So how the supply current will be traced? From point B, it will flow through thyristor P3, it will come back towards the load, and from point B, it will move towards the thyristor P4, then goes back to negative. It means we have received a positive polarity output voltage between an angle 3 pi to 4 pi when thyristor P3 and P4 are conducting. Now we will switch over toward the negative group of thyristors, because our motive is to find out the 1/4 of the supply frequency. So we have completed 2 cycles where we have achieved only half of the positive supply across the output. So next half of the cycle across the output will be received from the negative group of thyristors. So now let us move toward the negative group of thyristors, and we see that we have applied input supply, positive input supply between an angle of 4 pi to 5 pi. So once we have supplied a positive input supply, then this C point will be positive and this will be negative. So thyristor N3 and thyristor N4 will be in forward conduction mode. So we will supply a trigger pulse to thyristor N3 and N4. Similarly, in positive group side, thyristor P1 and P2 will be in forward conduction mode, but we will not supply any trigger pulse to thyristor P1 and P2. So let us complete the circuit, that once we have positive cycle, that is between angle 4 pi to 5 pi, so how the thyristor will complete? From positive switch point C, current will flow through the thyristor N3, it will come back toward the point B, and through load it will go toward this side and through thyristor N4 it will complete the circuit. It means in this case we have received a current flow that is opposite to the previous case. In previous case current was flowing from A to B, but now in this case current is flowing from B to A. It means the polarity is reversed. So we have received the negative output polarity as shown here. So this is the negative output polarity when you have received, that is when thyristor N3 and N4 are conducting. Now let us see, when we supply a input voltage, that is negative cycle input supply. So once we supply negative input voltage between angle 5 pi to 6 pi, then this side will be positive and this side will be negative. So thyristor N1 and N2 will be in the forward conduction mode. It means we will supply now trigger pulse to thyristor N1 and N2. So how current will flow? From the point D through thyristor N1, it will flow towards the point B, and through load it will come to the point A, then it will flow through the thyristor N2 and complete the circuit. It means during the negative half cycle between 5 pi to 6 pi, thyristor N1 and N2 are conducting and we have received the negative polarity output voltage. Let us move to the next half cycle. That is, the next half cycle we have applied the input supply between 6 pi to 7 pi angle. So this is the positive cycle. Now this point will be positive, this point will be negative. So point C will be in the positive mode, forward conduction mode. It means thyristor N3 and N4 will be in the forward conduction mode. So we will supply a trigger pulse thyristor N3 and N4. Now the thyristor P2 and P1. So once we supply trigger pulse thyristor N3 and N4, how the circuit will complete? From the point C through thyristor N3, supply will come here to the point B, and through load to the point A, it will come back to the N4 and goes back towards the negative. It means in this case thyristor N3 and N4 are conducting and we have received the negative polarity output voltage. So finally at the last, when the negative supply is applied as input between angle 7 pi to 8 pi, so this will be positive and this side will be negative. It means thyristor N1 and N2 will be in forward conduction mode. So we will supply a trigger pulse thyristor N1 and N2 only. Will not supply in the trigger pulse thyristor P3 and P4. So how the circuit will complete? From the point D through thyristor N1, it will come back toward the point B. Then from load, it will go to point A, then back to the thyristor N2 and goes back to the negative. It means during this conduction, thyristor N1 and N2 are conducting and we have received the negative polarity output voltage like this, which has been shown here. So by looking toward the waveforms, what we observe that once we supply a 4 cycle input supply voltage across the cycloconverter, we have received the output voltage, that is the 1 cycle output voltage only. If you take the average value of this positive group and average value of this negative group, we will get the sinusoidal supply of a single cycle only. So what we can see that from 4 supply inputs voltage which have applied across the cycloconverter, we have received only single cycle output voltage, or we can say F naught equal to 1 by 4 of the input supply frequency. It means we have stepped down the supply frequency across the output. That's why it is called the step down bridge type cycloconverter. So this is the overall control operation of the bridge type cycloconverter. If you like this video, then please subscribe this channel for more videos.